A while ago, the founder of Bentley Systems said that digital twins represent the greatest opportunity for IT to add value to the physical infrastructure industry since the personal computer. Recently, the United States announced a $285 million investment in an institute dedicated to building digital twins for the semiconductor industry. With similar investments being made globally, the market related to this technology is estimated to reach $47 billion by 2027. Given these developments, we might ask ourselves, have digital twins come to revolutionize production? Is the production of goods and services being transformed forever? How is this technology applied in different industries?
Digital Ritual is a podcast by Digital Pilgrims. In this season, Lauren Johnson and Paul Chase read the present and, together with other experts, try to unravel the future. Join them as they uncover the mysteries of a new reality.
Welcome to a new episode of Digital Ritual. In this installment, Paul will present the revolutionary impacts of new digital technologies on production. He will delve into the increasing funding for digital twins and how they are applied in different industries. Later, I had the opportunity to chat with Gabriel Spitz, Chief Business Officer of InAll Media, about the advances that digital tools have in software production today and the impact this has in several industries. Let's explore a new way in which digital technologies are transforming our world. Let's see what Paul has discovered about the digitalization of production.
The enormous advances in generative artificial intelligence and large language models are changing the scale and speed at which new digital products are produced. In the face of the increasing speed and magnitude of innovation, it is worth asking, are we entering a new stage of the digital revolution? If we dissect the processes inherent in digital transformation, we might think that not too long ago, software development was done in an artisanal manner. All the work fell into the hands of digital workers, programmers, and increasingly specialized engineers. The inclusion of generative AI and other emerging tools in software development suggests that the digital revolution is entering its industrialization chapter. The trend to increase the automated percentage of production in digital technologies becomes the prelude to a new era, a qualitative-quantitative leap with the potential to shake the foundations. In this context, digital twins emerge as a key technology gaining ground across a wide range of industrial sectors. These virtual and dynamic representations of physical objects or systems allow for real-time simulation, optimization, and improvement of processes, significantly impacting efficiency, quality, and sustainability in various industries. The ability to create virtual replicas of products, processes, and systems is revolutionizing the way we design and manufacture, which in turn impacts the efficiency and quality of production. The collaboration between NVIDIA and Mercedes-Benz stands out as a particularly interesting case of digital twin application. Using NVIDIA's Omniverse platform, Mercedes-Benz has created digital twins of their production plants before physically constructing them. This has allowed them to identify potential issues, improve ergonomic conditions, and predict robot failures, all before starting the physical construction of the factory. This application clearly shows the benefits of digital twins in terms of cost and time savings, as well as their potential to optimize processes and improve production efficiency. According to Fortune Business Insights, the digital twin market is nearly $18 billion and is projected to grow to $259 billion by 2032. While North America leads in adoption, Europe and Asia Pacific follow, with countries like China, India, Japan, and South Korea actively incorporating digital twins into their industries. The implementation of digital twins is gaining ground in regions of the Middle East, Africa, and South America, particularly in sectors such as oil and gas. Given the measurable impact already being observed, digital twins will undoubtedly be a key piece of the transformative potential of emerging digital production. Several sectors are being transformed by innovations in this area. Digital twins are already being used actively to predict and manage weather events, and in logistics to implement autonomous navigation. In conclusion, Digital industrialization, driven by technologies like digital twins, is transforming how we design, manufacture, and operate across various industrial sectors. While the benefits are evident, there are also challenges and open questions about how to fully leverage the potential of this technology and address its possible implications. What exactly are digital twins? What are the current uses of digital twins? What can we say about their developments in the near future? These are some of the important questions we need to address as we continue exploring the opportunities and challenges of digital industrialization.
To delve deeper into today's topic and to see concrete examples of the changes that digital technologies bring to the productive world, we invited Gabriel Spitz. Gabriel is an engineer and CBO of In All Media, with extensive experience in the technology sector. Gabriel, welcome to our podcast. I'd like to start with an overview of the current landscape. Do you agree that we are witnessing the early signs of the digitalization of technological production?
Hi Lauren, thanks for having me. I think anyone involved in the world of digital production or closely following sector developments knows that the landscape has changed a lot over the past 18 months, right? It is that the advent of generative AI and numerous new tools has completely transformed the playing field. As you said, I believe we are in the early stages, or the dawn, of digital industrialization. In concrete terms, we are entering a process of transformation and modernization of production and management systems. This is being enabled by the adoption of digital technologies such as automation, artificial intelligence, the Internet of Things, robotics, data analytics, digital twins, and cloud computing in industrial operations.
Is this a process that is already underway? Do you see interest and openness from companies to adopt this technology?
Definitely. Significant changes in production are already starting to be seen. We are already advising clients on implementing digital twin solutions. The key is planning where in the process to incorporate these tools. Beyond the vertigo and reluctance it may generate, it is important to move forward with firm steps. The potential of generative AI is enormous, and not giving it a chance or making an effort to integrate it into a company's internal and external processes would be a mistake.
One of the main concerns regarding the use of artificial intelligence for software development is the likelihood of the code having vulnerabilities. How do you address that risk?
Well, that's a big issue. Due to the way these models were trained, we don't know if the sources they learned from are secure. They may have contained code with vulnerabilities. In addition, we cannot ensure that the code generated by the AI will not be replicated elsewhere or be the same as what was provided to another client. That would be, wouldn't want that. This is because AI is opaque in its architecture and functioning. In our view, the key lies in how we incorporate AI into the software production model, the when and the how. We are exploring some ideas related to how we work in conjunction with new digital tools. For example, we have conducted proof of concept tests where we achieved very good results by rethinking the test-driven development, TDD methodology, which has been applied since before automation became prevalent. Let me know if I'm getting way too technical.
Not at all. Maybe you can give us a concrete example to better understand the role of these technologies in software production. Can you explain what this implementation entails?
Of course, let's break it down. Test-driven development is a method for creating software that focuses on ensuring quality and efficiency above all else. It consists of 3 steps. First, a test is created that defines what the software should do. Then the necessary code is written to pass that test. And finally, the code is refined for optimization. This process is repeated for all software functions, ensuring it works correctly and is easy to maintain. This method lost some followers because when used in classic software production, it increases initial development time. Maintaining tests over time often adds additional effort to the development process. However, today we are seeing very good results by applying the TDD methodology to the new technological landscape. That is to say, for example, large language models allow us to quickly write test code, and automation allows it to be constantly run against the developed code. The development team produces code that is continuously tested, working alongside automation to create a more elegant and effective product. Essentially, our idea is that this version of test-driven development circumvents the two major problems of including artificial intelligence. The vulnerabilities in the generated code do not pose a risk to the product because they only exist in the test, which will not be part of the final product. It is only used to evaluate its production, and also it is an intelligent and efficient way of collaborative work between people and digital tools. We harness the speed and analytical power of the tools without sacrificing the creativity of human developers. The result is functional and reliable code.
In a present where there is constant talk about AI replacing workers, it is encouraging to hear you talk about collaboration. You mentioned that you recently started implementing this methodology. Do you already have preliminary results on the impact of this change in production design, or is it too soon?
Well, although we started with these changes relatively recently, the results, they are more than interesting. We are working on proof of concept tests to incorporate this methodology into the development system with some clients, and we already have numbers showing processes between 25% and 30% more efficient, which is, quite interesting, to say the least. Additionally, they demonstrate that it facilitates the subsequent maintenance of tests, saving effort throughout their life cycle. We are even seeing that it is extremely efficient for updating complex systems from older languages to newer technologies, as we start by creating the tests from very stable functionalities that then allows our developers to focus more on efficient refactoring and code improvement.
Does this mean a significant change in the way digital products are created?
Yes, undoubtedly, it is a step in a very interesting direction. This method of development safely incorporates the use of artificial intelligence into large-scale software production. Our priority is always to develop reliable and secure code for our clients, and in this way we are laying firm foundations to minimize costs and accelerate productivity gains. The efficiencies these technologies offer are enormous, and those that apply them will certainly soon see a competitive advantage in the sectors where they operate.
These innovations herald the beginning of a new era for software thanks to artificial intelligence. Is it the same with other innovations? Do you have an example for the implementation of digital twins?
Yeah, sure. Let me briefly point out something interesting about this same case. The working logic is similar to that of digital twins. By creating the test up front, we have the final product's tests before we have the product. In essence, we are comparing our development with the end product we want to achieve. That is, essentially, we are creating a kind of twin of the product that allows us to develop software in parallel that closely resembles it.
I have one last question before we finish. Do you think these tools and methodologies are applicable to processes of any size?
Without a doubt, it is something I would recommend that anyone dealing with complex production designs explore its capabilities. Regardless of whether test-driven development or the development of digital twins is the way to go for a given company, we fully believe, it is worth exploring what digital tools the market offers so each company can maximize its resources for their various challenges. At In All Media, we receive on a daily basis inquiries from companies needing to evaluate the application of these innovations and adapt them to their specific needs. It may not be necessary to have a digital twin, but it's certainly important to analyze which parts of the processes can be empowered with AI and a myriad of solutions at our disposal. No matter the industry or the size of the company, it's important to ask these questions, Digital industrialization has the power to change things for everyone, and it can do so very quickly. We have had great results assisting companies in human resources, quality and precision, logistics, even fintech, companies with systems of all sizes and complexities. Today, more than ever, it is crucial to stay competitive in a changing landscape and adapt quickly.
Thank you very much, Gabriel.
My pleasure.
We just heard from Gabriel Spitz, CBO of In All Media.
This is a Digital Pilgrims podcast, sponsored by Coderful, the service management platform for remote teams that is transforming the industry. Subscribe and find out more at inallmedia.com. Digital Ritual, the urgent questions.